Yes, sir.
Yes,
Good
sir.
afternoon.
Okay, sorry,
Good
I was having
afternoon.
connectivity problems, so I couldn't connect. So let us get started. Uh, so I'll share the presentation. Is it visible now?
Yes, sir.
Okay.
Yes, sir.
Okay. So we have been discussing about SDLC, software development life cycle, and we have had a discussion on the major stages of this development, where certainly there is a specific input for every stage and a specific kind of output expected, starting from requirements gathering and initial analysis, where we interact with the customer and try to document the requirements after analyzing them in terms of an SRS, software requirement specification document. Uh, Next, the design phase, where we use the SRS to go into the architectural design, separation of software and hardware components, separation of functional and non-functional requirements, and specifically we try to represent the design in terms of unified modeling language, typically using use case class sequence kind of diagrams to lessen the dependency on the natural language. And once this is done, we go into a little bit more depth, getting the high level design of classes, interactions, interfaces, and finally get down to the low level design, which talks about the algorithms, data structure, and all that. And then it moves on to the, with all these details, it moves on to the development phase, where the actual coding is done, implementation of different components, and alongside the unit testing of these components keep on happening. And we try to complete the development of all these components and their interactions and integrate them together and move on to the testing phase. While testing had been going on during development, but it is more unit oriented, or maybe in terms of module to module interaction only. But in testing phase, we test the entire software together. So it has been integrated, and a variety of testing methods exist. As I mentioned, we will talk about those later. And often testing happens based on a separately developed test plan, which is executed primarily by a separate testing or quality assurance QA team, who report back to the development, and bugs need to be fixed, and it might go back to design or to requirement analysis and so on. And once the testing is completed and the software is ready at the site of the organization, at the site of the company, then it is put to deployment, where it is installed in the customer's environment, in the customer's infrastructure, to see if it is working. And if it is a relatively middle or big size software for multiple users, then often there will be a limited deployment done for user acceptance testing, or UAT, through which the user can see what has actually been implemented and test that and give their report, and again bug fix loops start. And once that has happened, then the software is deployed and goes live. It is called the go live in the industry. So go live is when the actual users start using it. And if there are bugs reported, then it gets into the maintenance. Small bugs can be fixed. If there are bigger requirements because of business changes or because of the dynamics of the whole process, then there could be separate versioning of the software, and the entire set of stages might get executed once again. So this is kind of the set of stages. Now the question certainly is, how do we execute these stages? Do we execute them in a linear manner? Do we execute them with certain feedback in the process? Do we execute them iteratively? what kind of mechanism should we involve, and what is the point? What are the points where checks and balances must happen? We talked about the management control. So naturally, the the more of the checks are done on a regular basis, the possibility of a bug staying in the system for longer time gets reduced, and that minimizes cost, improves quality. But certainly, checks also have their costs because it involves manpower, it involves time, it involves money, and so on. And very importantly, the question is, when does the customer actually gets into the loop? Does the customer get to see after the software has been completely built? Then there could be a lot of issues in that. Does the customer get to see it in the middle? But then if we are following a linear kind of model to develop the software, how does the customer see? I mean, what will the customer do by seeing the design? Will the customer understand the design? Customer is not expected to be kind of educated enough to understand the design. It's always possible. So there are different choices of SDLC models which decide primarily how do we involve in these stages, right? So we will talk about different such models and try to see the trade-off between them in the next couple of slides. So this is just to give you a very rough idea of the timelines of evolution of these SDLC models. Certainly, software started getting developed seriously in the 50s when it was just like you code it and fix it. I mean, kind of the developer listens to what is required, code, fix that. 60s went more into the design phase, that there is a proper design required before the code, and there's a proper testing and maintenance required for that because software started expanding. 70s saw a more formalization of software engineering and the emergence of what is known as a waterfall model, which is certainly one of the very predominant models till date. 80s and 90s saw the evolution of spiral model, rapid application development, prototyping, V model, and so on. And from this millennium, we started migrating, at least partly, to agile methods. And of the last decade or so, what has taken the center stage is a specific kind of agile method called Scrum. So this is a spectrum. Of this, we will talk from the 70s till date. Because these are what is currently in use. The earlier methods have got subsumed in the later methods and are not in use really. So waterfall model, which is most commonly used, for example, what is described and what you would be doing in the assignment 3 and assignment 4 would be typically the waterfall model. In this model, each phase will start after the previous phase has been completed. Each stage goes in a linear manner. So you complete the requirements, then you do analysis, complete the analysis, you do design, complete the design, do coding, then you do testing and the software product. Right? So if you see the document of assignment 3, you will see that these are the different sections, which just as a sample, I mean, kind of outlined what should be there. But you will have to refine them more and more so that you can make a right product. But this is the waterfall model. It goes in a linear manner. Right? Now, naturally, if we try to evaluate what are the strengths and weaknesses of that, naturally the strength is very easy to understand. I'm sure all of you have gone through the assignment 3 document and have understood more or less, because I did not get. I just got 2 or 3 questions, but not many really. So this must be more or less easy to understand. One second. So achievements are very well defined. So it defines the requirement stability pretty much, and works well when the project quality is important, right? Because you are doing every phase very meticulously, and possibly at every phase you have specialized people in the project team who focus on that and have experience on that. But it has several weaknesses, which is primarily, one is it does not match the reality well. The reality is, just think about it. Suppose a software, say a stock trading software, takes, so for the stock trading software, you will have to make different components. One is certainly the depository component where you keep your DMAT shares. So you have to connect to NSDL or CDSL for doing that. One is the banking component, because whoever is buying or selling stocks have to transact with the bank. So there's a banking component. There is an actual component with the stock exchange where you interact with the stock exchange to get different, buy and sell quotes and put your buy or sell request, and they get satisfied. There is a reconciliation component which finally says that how much you have bought, how much you have sold, whether you have to deliver those shares or get shares, give money, get money, and so on. So it's a complex system. So it'll, in a reasonable scale, such a system will require 1 to 2 years to develop. Now, naturally, during this time, the problem is certainly the developing company needs to get paid on a regular basis. But the customer company, the customer does not get to see what is actually happening. How far is the progress? So payments become a big issue. You'll always have to think business when you are in software engineering. It's just not the engineering. So payment realization becomes a major issue. There could be, it could be very difficult to make changes. If you have misunderstood something, then it has gone deep into the implementation and very difficult to come back and make changes. And the software finally gets delivered towards the end of the project only. So customer is there only at the start of the project at the requirements and only at the end of the project at deployment. So testing truly begins after the development phase is complete. So this is the right recipe to build a wrong system. You may be able to, by following your processes, may be able to build the system right. Make sure that it does not have many bugs in terms of the specification, in terms of the analysis design. But if the specification itself has been incomplete, or specification has been understood by you in a wrong way, then the whole thing has got implemented. So it's very easy to build a wrong system in this model, right? So waterfall works particularly when software projects that are stable, which do not have do not have much changing requirements, and where it is possible that designers are able to fully predict the problems. That is, designers are so very conversant with the domain that they understand, like the customer, as to what is really could be the problem or what is really the requirements. So where it is possible that the designers produce a correct design, right? So in those contexts, it is a good model, and for a small one, it's a good model, right? Like the one you are doing in your assignment 3. This is a typical, fail late life cycle model, where we are showing that this is the time axis. X is the time axis, and these are the different phases which are happening kind of linearly. Requirement analysis, design, implementation, integrate, and system test. And y-axis is the potential impact of risks being tackled. So just think of it, if you have a problem in the requirement analysis phase, some inconsistency you found, or some incompleteness you found, and you try to fix that, the cost for that is very, very less. So you have the impact of the risk of failure is very less. If you go later on and you find it in the design, then it has already gone into the design of multiple modules. A lot of effort has been put to finalize the requirements and analysis. So if you find a bug at that point, then it might mean that you have to go back to also change the requirements, analysis of that, look into those, make changes in multiple modules in terms of the design, so your cost gets higher. Even later, if you find it at the implementation stage, then you might have to roll back on your design, on your requirements, redo them. Your work is even bigger. So as you see that as you progress on time, your risks of the impact of the risks are growing higher. And finally, when you integrate and do the system test, and mind you, in this model, that is the time when the customer actually gets to see they are doing the UAT, user acceptance test, and a bug is found. It may be a simple coding bug, so it gets back to implementation and it's fixed, not a lot of cost. You can see the gradient here. It may be a design bug, so it has to go back to the design, some bit of gradient, but it could be often a bug in terms of the understanding of requirements. I mean, you saw the swing hanging from the branches of the branch of the tree example, metaphorical example. I'll also show you what customer actually had asked for at a later point. You'll understand that. So if the problem, and oftentimes the problem is there, so you can see the whole gradient. You have to go back and rework through the whole system. It's a huge amount of cost, right? So you have payments problems, you have high rework risks. So waterfall model becomes, it's an easy model, but it is easy to follow, as well as it is very easy to fail a system because you are following the waterfall model. So a bug found in early stages is cheaper in money, effort, and time to fix than the same bug found later in the process. It's quite understandable. An early defect that is left undetected until development or maintenance is estimated, and this estimate is not rule of thumb or ballpark. These estimates are based on data of thousands of projects that people have reviewed, to see that something which, a design bug or a requirement bug, which was found in the maintenance time, will cost about 50 to 200 times to fix if they were actually caught at the requirements time or the design time, right? So late bugs make the projects fail. And that is the reason that typical success rate of projects implemented with waterfall model goes less than 15%. Success in terms of quality, time, and money. All these three factors are included. Right? So there came a concept of a second model, which is called the iterative refinement model or iterative incremental model. What you do is you do micro phases of iterations of waterfall. So what you are building in the first iteration is the overall system, but at a somewhat of a limited functionality. So if I talk about say the booking system we have seen in the assignment, then you are building that entire booking system, but you just have the basic booking rule of how to compute a fare by distance, and you have just a concept of booking class to load that, and you have no passenger information. But you can show that, okay, by taking these two, I can compute the booking and I can give the output in this way and so on. A quick round can be done on this iteration, and at the end of this iteration, you could show something to the customer, but to tell them that this is not complete. This does not have many things. Come to the second iteration where you say, okay, I'll be able to do this also including certain booking categories. You can not all tickets every seat or berth on the train does not cost the same, even in the same class, because I could have special concessions for senior citizens. I could have special concessions for the differently abled, and so on, right? So I take the category information in this and refine iteratively, incrementally put that in, and again do a waterfall here in this iteration too. I still do not have passenger information. So what I'm doing, I'm showing that if the, the passenger, I hard code say, if the passenger is a senior citizen, then this is the way it will go. It will pick up the uh, price concession for senior citizen, and this concession will be given. Again, you show to the customer. So incrementally, the customer gets to see after every iteration, but each and every iteration internally is following a kind of a waterfall model. And then you come to iteration 3, where you bring in the customer data, so that from that data you generate that if the customer is a senior citizen, or if the customer is differently abled, or if the customer is is eligible to get a ladies seat, and so on and so forth. And you complete the requirements in terms of this. You have not seen this iteration 2, iteration 3 parts of this assignment. This is what will be coming in assignment 4. So what necessarily you are doing is you are going through the waterfall every time, but you are in every time you are building the complete system with certain requirements, and as you go to the next iteration, you increase that those functionalities that you have put in, and kind of cross check with the customer. So the process, this number of iteration keeps on getting repeated until the product development cycle gets completed. That's all requirements are satisfied. So kind of in your assignment 3, 4 together, what you'll do is basically an iterative incremental model, which internally for every iteration of your assignment will do a waterfall model. So this is certainly somewhat better than the waterfall model. So the strengths of the iterative incremental model include that you have prioritized requirements can be initially developed. I mean, what is your primary requirement of booking? That you must be able to book. Stations are primarily important. From where to where you are going, how much distance, right? So that you should be able to do first. Second is your booking classes. Third is your booking categories. Fourth is getting the passenger information into that. So you can prioritize your requirements, and you can define iterations according to that. So the initial delivery of the product gets faster. So you have a lower initial delivery cost because you are just doing a cartel down set of requirements only. And naturally in this process, it will become easier for the requirements to be, I mean, if they're changing, it is easier to get adjusted, right? So the customer gets to see, so customer, instead of being at the start, at the end of iterations, is a start and end of the project is now there at every iteration. So customer gets to see multiple iterations. Those could often be your milestones and payment points. So it becomes easier for your accounts team to raise the invoice and get the payment done. It gets easier for the customer to have confidence on you, and so on. But there are certainly weaknesses of this model as well. There are requirements for effective iteration planning. Planning these iterations are not trivial. For example, I mean, in the booking example, you have to decide what are your priorities, what iterations will make it a complete demonstratable system to the customer, and so on. Efficient design is required for including required functionalities. If I go from one iteration to the other, and if I have to trash the entire design that I had done in the previous one to the next one, then it will not remain cost effective. But that means the design gets needs more maturity to be done. An early definition of a complete as well as fully functional system is required, which may not be easy for all systems. So clear module interfaces and so on. So it is a better system in terms of system realization, customer engagement, in terms of interfacing properly for engineering, but it is a more difficult process model to follow, right? So this is also is quite often used even today. The third is a kind of variant, which we say is a V model. it is called the V model in a multiple allegorical form. One is it has two parallel phases that go in sync. One is called the verification phase, that is going through requirement design, high level design, low level design and code. And one is a validation phase, which takes care of the testing. Right. So partly inside this is this is like a waterfall. But here, I'm sorry, it is testing is also happening in a linear manner. So verification and validation, two V's give you the name V model. And if you see this architectural form, it looks like a V. So quite allegorical. So what happens here is as you go over from requirement analysis to the low level design, and then you start coding, then after with the codes happening at the design time, we said we'll do unit testing. So unit testing happens with the low level design. So when you are doing the requirement analysis, a separate team is doing an analysis on the requirements to decide what are the tests required to finally accept this system. What is the UAT? When you refine that at a system level design, you have decided on the architecture, you have decided on software, hardware partition, functional, non-functional requirements. The correspondingly, the test plan for system testing, testing for this architecture is working fine, testing for this functional requirements, non-functional requirements, once fine, is getting prepared. Then you do a high level design, and correspondingly, integration testing test plan is getting developed. You do a low level design. So now you know your classes, now you know your interfaces, so corresponding unit tests are getting developed. But these are only on the left, these are actual execution. On the right, these are all plans right now. Because the thing to test does not exist. Now, after the low level design, as you get into the implementation, the development phase in terms of the development stage in terms of the SDLC, as the coding happens of different low level design components, you have the unit test plan and you perform unit testing. So they are happening in sync. So the low level design is available to the unit testing unit testing team, which takes the code and unit tests. And this will progress only when this has been cleared. And when this has been cleared, then your code should be ready to be able to do certain level of integration. So your high level design now should be testable against this integration test plan. And it keeps on as you do more and more in your coding, it goes from the unit level to the integrated modules level to the systems level and finally to the deployment level. Your testing progresses in sync with this. So this is quite an integrated process, which naturally makes the checks and balances better. So V model tend to give a better quality than a plain and simple waterfall model. So it is simple, easily understandable. V model approach is good for smaller projects. For example, the project that kind of the assignments you are doing in 3 and 4, you could pretty much do the V model yourself because the requirements are defined and frozen at an early stage. And as I said, there is a systematic and disciplined model, so it results in a high quality product. But the weakness is that V-shaped model is not good for ongoing projects. As I talked yesterday, that the bulk of software engineering is also involved with live projects that need bug fixes, projects that need your versioning, new requirements are to be put in and so on. Because certainly this is an integrated model on the design side as on the test side. So once it is done, for a new project, it is good, but for an ongoing project, V-shaped model is difficult to do. And if the requirements change at a later stage, it could cost high because as you have seen, if I go back to slide 23, as you have seen, if you have a change here, then you have ripple effect not only up to this, but you have ripple effect on the right side on the tests as well. So this entire V gets impacted if your requirements have changed. So change of requirement is the reality of the kind of software. So again, in terms of customer engagement, it is not very high because customers are again engaging only at the start and end only, but it works well for small and new projects, right? So this is another model. Uh, the next that I'm sorry. Is what is called a prototyping model or a rapid application development model. After trying this kind of models, people started understanding that engaging customer earlier on in the system is a critical requirement. Customer must be able to see what is happening, and the only way you can make that happen is if you start building prototypes of simplified versions of requirement. Again, prototype models have limited functional capabilities. Sounds pretty much like the iterative incremental. And when you build a prototype, you will insert dummy functions to create prototype. For example, in the booking, when you are putting in categories, you do not really have passenger information. So you do not know if a passenger is really a senior citizen or not. So what you do, you put a dummy information. You say, okay, let the passenger be a senior citizen. I hard code it, right? So, but you can create the prototype for the later stage. So prototype built prior to the actual software at multiple levels can get valuable feedback from the customer. Then slowly you replace the prototype with a bigger and bigger actual implementations. But the feedbacks could be critical in terms of this implementation. And certainly this goes on till the model is accepted by the customer. So you gather the requirements. Then you do a design, prototype, customer evaluation, refine the prototype. You keep on going in this loop. And we will see that how this quickly leads to a spiral model. And you keep on doing this till your final product is ready. But you are always working on a prototype instead of going linear on the entire system and putting it together. Naturally needs more analysis. So the rapid application development of the RAD model, which is primarily how the prototyping is done, is based on prototyping done with iterative development or iterative increments. So you are doing different iterations, but iterations are generating different prototypes, and often this is done with with a little bit of maybe with a little bit of different approach, that you could divide your entire system design in terms of kind of independent modules, not totally independent, but minimally interacting modules, and engage different teams to develop the prototype in parallel. So team 1, team 2, team N, developing different parts of the prototype in parallel. Each one of the team is following an iterative incremental process according to their subsystem specification. And but these are happening, prototyping is happening together. So in a quick turnaround time, you can show a prototype implementation to the customer, get your invoices cleared early, and the customer feedback is critical for all these teams to refine the prototype. Usually for short lifespan projects, this is very, very effective because this can be done in a quickly reduced cycle time, enhances the productivity with minimal number of team members, and customers' continuous involvement ensures minimal risk of not achieving the customer satisfaction, because the customer is getting to see the prototype multiple times. So it also makes it easier to accommodate any change. Again, the flip side is it is hard to use and implement with legacy systems because everything is built. You have to do a sub-prototyping model that wherever the change is required, that part you have to be able to cull out as from the existing full-blown system and make a prototype for that with the intended refined functionality or revised functionality and try to put it in. It's a difficult problem because the legacy system may not have followed this model of development, so the legacy system could be pretty flat. It may not have followed an purely object-oriented design. It may not have followed a proper object-oriented language and so on. So this RAD model gets heavily dependent on technically strong members who can identify the business requirements right and define the prototype. So these are some of the weaknesses, but overall, it is good in terms of the fact that the customer is there at the prototyping. Works well for fast development priorities, for smaller development. RAD is also done for development for estimation. For example, you have a big project, say the railway reservation system. Overall, I mean, that's just not the simple, kind of reduced booking system you are doing. The overall reservation of trains, dates, berths, availabilities, eligibilities, and so on and so forth. Now, if you have to quote for the system, how do you estimate, what is your resource requirement? What time will you need? How much manpower will you need? So just analyzing the requirement, you will not be able to get to that. And it will be very, very huge. You will need to do the analysis of the entire thing. You will need to do the design of the entire thing. And then it comes down to doing the project itself. So that is where prototyping can help, that you can take subsystems, make small functionality prototypes and see how much effort are you taking. So if say a railway reservation system is of 100 man-years effort, then you could probably spend a 5 man-year effort, say 10 people working for 6 months, 5 man-year effort to make small prototypes of different components and get an better idea of what is really involved. And that data can be fed to the estimation of the project cost. You have to keep the business always in mind, starting from whether you are doing quotation to whether you are finally doing delivery, whether you are raising invoices in between, and your engineering has to be able to very tightly coupled with this sales requirements, with this marketing requirements, and with this accounts requirements. So this is where RAD could be useful. As I said, along with RAD, as you are going through these different iterations, you could do a more formal risk analysis. So this is called a kind of a 4-quadrant model, where on the left you do planning, next risk analysis, then engineering, then evaluation. So you are doing the same thing of prototyping and iterative refinement, but what particularly gets this name spiral model is you are going through this for every stage of the waterfall. And the critical thing is the risk analysis. That it's not only you are engaging the customer to get the feedback, but you are also assessing that given what you have done so far, what is the risks of failure and how to mitigate those risks. Risks will always be there. Unless there are risks, people will not pay you. You are getting paid because you can you can mitigate the risks better than others, right? So you have to get a more direct, idea about the risks, and that is how the spiral model goes. So somewhat these are pretty interrelated, as you can see that a flat linear model will not work beyond a certain project size with reliability. So these iterative refinements, prototyping, rapid application development, and going over them in spiral are some of the process tools that you need to get your development better. So spiral model strengths will be an early indication of the risks can be provided when you have not incurred much cost. So user can have a look at their system early due to the RAD, due to the rapid application development. User gets involved in all life cycle stages because you are spirally going about them. and critical high-risk functionalities can be initially developed. Right. So this is the spiral gets better in that way. Certainly the difficulties or weaknesses involved, that is hard to set the objectives, verifiable milestones to indicate the preparedness to go with the next iteration, because you are always in an uncertain environment, because you are kind of assessing the risk, trying to mitigate, and then trying to make changes based on what the customer has told you. So time spent on addressing risks can be large for smaller, low-cost involved projects. So like RAD is good for smaller projects. Spiral will be good if it is typically a bigger project where you can have all those investments. And it's a complex model, so new members will have difficulty. So you have to have a good mix in your team of new members as well as experienced members. And since it is getting round and round, like the iterative incremental model, there is a potential risk that it keeps on going indefinitely. The customer never gets satisfied. Customer is always right, and the customer is looking at the system as you do the RAD, refinements of that, and so on. And the customer is always, so it has to be contained in that way as well. So there are some of the pros and cons of the spiral model. But the big advantage is customer is at every spiral round, which improves quality, reduces rework, but potentially may slow down the development. So it will increase cost, right? So this is, you have to keep in mind. Finally, the talk of the town, talk of the world is agile model. All of you must have heard about this. Agile model is a combination of the iterative incremental model that depends on the process adaptability along with customer satisfaction. If you look at in the whole spectrum that we have discussed, a major issue we always had is how much the customer is engaged, how much the customer is informed, how much the customer can see, how much the customer can give feedback, how much the customer is getting satisfied, and so on. And the other side has been that how adaptable or changeable is your process to do different kinds of iterations, different kinds of rapid prototyping, and so on. So when you break it down to a really micro level, you get to this agile model. So agile model, if you see the iteration of every agile model is like the life cycle stages: requirement analysis, designing, building, testing, and then you have a planning for the next requirement analysis. You keep on doing like that. Every such round happens in a short time span, maybe 1 month, or maybe at most 2 to 3 months. So you are going like this, and at every point here, you try to get the customer engaged, right? So this is the reason you call it agile model, that you are very agile. Agile is very active, hyperactive, right? You're agile to accept changes. So it is very easy to accommodate changing requirements. Regular communication has to take place between the customer and the developers. We will see what are the mechanisms for that, because you're slowly moving from waterfall to now we have come to agile, and you have seen that through this process, two major things have changed. One is from a linear, bulky, very well planned development with very low customer engagement. We have moved to more and more micro loops, micro developments, and bigger and bigger customer engagement, right? So there's a gradual migration in that way to make sure that you can deliver better quality at a lower cost. So regular communication now has to happen between customers and developers. Functionalities can be developed quickly and demonstrated to the customer. So you're not talking about the entire functionality, you're talking about micro functionalities now. So this means that if you have to do that, this is not ideal for handling very complex dependency. So the design paradigm also has to change, and that's where again object-oriented analysis and design gives you a lot of advantage because you by design of proper interfaces, you can get really independence between the classes that you have. And you need to have teams with desired experience level because the risk of the whole thing is that customer is always in the loop. So in other models where customer has a limited visibility into what you are doing or what your team members are doing, in contrast to that, here the customer gets to interact regularly. So customer gets to see, okay, team member X is doing excellently well, team member Y is not that good, right? The customer starts complaining. Well, I don't want Y in my project, give me Z. Z is doing a critical, project with some other customer. You don't want to spare Z because that's not the kind of money that the customer is giving. So this kind of contradicting requirements in project planning keeps on coming. But overall, Agile has become a kind of the de facto way to go for several projects. If you look into big companies across the world, including the big ones in India, like TCS, our biggest software company, actually the biggest company in terms of turnover in India right now, to any other medium to small companies, being able to develop in an agile manner is a major requirement of a large number of software development projects. So this is overall, before we break into and finally I talk about a specific agile way, the Scrum. So this is kind of I just want to give you some information in terms of a group called the Standis Group. You can look up their site and so on. They annually publish what is called a chaos report. Again, metaphorical. It stands for Comprehensive Human Appraisal for Originating Software. So it's they regularly survey different projects, their successes, and they determine what are the primary factors which cause success of a software project, what the software engineers should adopt. So initial studies in the 90s, and that, I mean, it's not only old data. This is kind of it still holds with certain different points in the present time. It identifies 10 success factors as are given here. 9 of them are concrete, 10th one is the rest. So it says that if I have 100 points to give for success, then how much point do I assign for different factors? So user involvement, the customer engagement, gets 20 points, which is the highest. That is, I mean, the higher of user involvement you can have in your software project, your possibility of success becomes higher. Executive management support and control, 15 points. Very important for the management, not to just assign the project to a team and then wash their hands off. Doesn't work. Clear business objectives is 15 points. You must know what is the priority, what is the quality that you want to deliver, how important is this customer, how much really you want to invest in this project, and so on. Clear business objectives. You need experienced project managers to be able to manage the project overall, 15 points. Then comes slowly the different things, and you can see that we actually occur not very high in this list. Competent staff is about 5 points. I mean, it's very important to have competent staff, but only having competent staff will not mean success. A much better component of success will come from this top view. So it's not necessarily that all projects will require all these 10 factors to be successful, but more of these factors are met, the possibility of a software engineering success gets higher. So the models, more and more of the SDLC models try to build in these requirements, these factorial requirements. So I just wanted to sensitize you on that. So based on that, if you look into the same failure curve that we saw for waterfall model, in agile it will look something like this. This is the time axis, and this is the axis of impact of risk being tackled. And you can see that naturally in agile you are doing multiple iterations. So initially the core impact of risk is very high because everything is not understood. If you have understood something wrongly, it's a high cost. But kind of as you go through the iterations, starts flattening out because you are regularly interacting with the customer, you are understanding the system better, you are doing the prototypes faster, you are making the more accurate prototypes, and as you go over the iterations and so on, it rapidly starts falling off, which is a huge advantage compared to the waterfall model where it was just going up and up, which is just the opposite of what you want. This is the opposite of what you need. So that is the basic, success. And these curves are not just imaginative drawings. These have been, empirically computed by surveying several projects by several agencies. So they're taken as iconic in the whole industry. So I think I'll stop here. We are almost out of time. So let me get back and see if you have questions. So I tried to talk overall about the SDLC models. I'm not sure how much it was digestible for you. I think tomorrow you should think over, and I'll share this. Okay, I'll share the presentation tomorrow. So you have seen through this. So please be prepared to ask me questions tomorrow. Tomorrow in the beginning, I would like to listen to your questions first, clarify them, and then talk about the last and final model, which is Scrum. Okay. Is there a quick question right now? We still have a minute or two to go.
So is TDD a part of the V model, or I mean, keep on hearing about it?
TDD is a variant of the V model where TDD is more in terms of automating unit testing. Test-driven development is primarily with automated unit testing. It is kind of a V model, but it is also being followed as a variant in the agile model. This is more followed now as a part of what is known as XP or extreme programming. Right. So I'll talk tomorrow a little bit about TDD. But it has not been well accepted yet because TDD needs a lot of support from the programming language. So a language like C++ or Java does not have the support to have unit test classes for every class. So just look up for language D. You can Google and see. There's a language D by Andrei Andreescu. This language D has this feature of having unit test classes, which is designed for TDD. But it's a little bit of a different track, not in the, we are talking about the primary line of business. These are all development experiments happening. So TDD is a more part of that, I'd say.
It's like more in the research phase now.
I would not say research, but there are trials. People keep on trying different things and then something succeeds. Like Scrum, I will show you that somebody tried in his company in 90s, and that proved to be a big success, and then it started expanding and has become the world accepted practice today. Right? TDD has not gone to that level at all, but there are active groups, there are active portals which support TDD, which is building language like D for TDD. There are certain add-ons that you can do. There is other factors like aspect programming which supports TDD, which are coming in, but not kind of the primary line of business. Right. Okay, we are completely out of time. Keep your questions noted. Tomorrow, I would like to hear about these questions. I really thank you for asking this TDD question. Any questions, any wild question or understanding on this you have, ask me tomorrow in the morning class, and then we'll talk about the Scrum and close on the SDLC. Thank you very much. Have a nice day.